Hello everyone. Today we will see uh, question number 63 of GATE 2026. It is the question from communication and error control coding. The question is asked here is the average bit rate at the input of 7, 4, 1 having decoder is 0.10. What they are asking is the probability that decoder will fail. Please understand the probability that decoder will fail to decode a received word. A Hamming decoder will receive a word. In that, there will be some error. That error is 0.10. Error rate is 0.10. The question is asking is what is the probability that decoder will fail to decode that received word? To solve this question, we need to understand few concepts. There are few prerequisites. We will see what are those. The first concept is linear block of codes, that is NKT. The second concept is decoding failure condition. The third concept is binomial distribution for independent bit errors. So we will see concepts one by one. The first concept we will see is linear block of codes. Linear block of codes. That is n, k, t. Here n is the block length. N is the block length, that is total number of bits in the transmitted code word. K is actual data bits. K is, you can call it as message length or actual data bits. Next you have T. This is nothing but error correcting capability of the decoder which we have. It means maximum number of bits can be corrected automatically by a decoder. Now, if we see our question, we have a 7, 4, 1 Hamming decoder. Right. So as per our concept linear block of codes, 7 is the N, 4 is the K, and this is the T. Please understand, we have a block with 7 bits, 7. Actual message is length is 4, and error correcting capability, which is number of bits is 1. The second concept we need to understand is decoding failure condition. Decoding failure condition. What is that means is, if number of bits, if the number of errors in a block greater or less than t, that is automatically correcting capability, error correcting capability of our decoder, then it succeeds. That means it corrects. If it is greater than t, if it is greater than t, it fails. Our decoder cannot correct the code word. Here we have 1. So if the number of errors in a block is 0 or 1, our decoder can correct that error and it succeeds. Please understand, if there are more than 1, it fails, right? Now what they ask in question is failure condition only. Before that, we have one more concept, that is binomial distribution. That is written as PXO n by x, n by x, that is n by x, p of x, 1 minus p, n by x. Here n is the block length, which we know already, that is 7. Then you have x. Probability p is called as bit error rate. Bit error rate. Then 1 minus p is correctly transmitting probability. Now, if you know all these concepts, you can solve the question easily. We have been given n is equal to 4, k is equal to 4, n is equal to 7, k is equal to 4, t is equal to 1. We have seen that to get the errorless transmission, we should have 0 errors or 1 error, because our correcting capability is 1. So we need to find the probability when there are 0 errors, probability then when 1 error. These both are success conditions. So to find out that, P of 0, 7 by 0, this is 0.10 by 0, 0.907 minus 0, it comes around 0.4782. Now probability of 1 is 7 by 1, it comes around 0.37200. So total probability is 0.47 plus 0.37. It comes around 0.85. So 1 minus P, which is 0.1 minus 0.85, which is nothing but 0.1496, which is nothing but 0.15. This is the answer for this question. If you have any question or doubts, please put it in the comments. Thank you.